This is a part one video of ground faults. I also have another video, kind of like a lab experiment that I can demonstrate what a ground fault actually is. So if you're interested more in ground fault protection, check out the next video. Thank you. Hey, welcome to another episode of Homeowners Electrical Professor. Welcome future electricians and homeowners. I'm your host. My name is Paul Esposti. As an electrician and as an inspector, one of the most commonly asked questions that I receive from homeowners when I'm testing out receptacles that are required to be ground fault is people ask me, what is a ground fault? Why does that kitchen receptacle have to have that? Now I'm going to take some time and explain a ground fault, what it is to you. So, ground fault protection is designed to protect lives. What is a ground fault? A ground fault occurs when the AC current or part of the AC current does not return on the normal path of current to the electrical panel. This means that part or all of the AC current is returning to the electrical panel on a fault path. If part or all of the AC current is returning through a human or an animal, this creates a hazardous situation. What is a fault path? A fault path is basically any current path other than the normal path. The fault path could be through water pipes, the grounding conductor, water, or even the earth. This is why ground fault protection is required in kitchens, baths, basements, outside, etc. I have a slide for protection from ground fault electrical shocks in this presentation. Residential ground fault protection can be provided by a ground fault circuit breaker or a ground fault receptacle. A ground fault circuit breaker will protect the entire circuit, either 120 volts or 240 volts. 240 volts would be used especially outside if you have a swimming pool for the pump and any heaters you might have. A ground fault receptacle will protect the receptacle and any receptacles properly wired to the load side of the receptacle. In earlier videos I talked about the line and the load. I'll go into that more. Residential ground fault protective devices are designed to trip at 5 milliamps, which is 0.005 amps, or 5/1000ths of an amp. Not very much. See the effects of electricity on the human body at the end of this presentation. A 120 volt circuit, the normal path of AC current is between an ungrounded hot conductor to a load and returns on the grounded neutral conductor. Remember I told you back when you were looking at me like everything, these were boring? Now it's starting to make a little bit of sense to you maybe. The AC current on the hot and neutral conductor will be equal. If a ground fault occurs, part or all of the AC current will be returning on the fault path and not on the neutral. The AC current will not be equal on the two conductors. Ground fault in a 240 volt circuit. A 240 volt circuit has two hot conductors supplying a load. The AC current between the two conductors will be equal. If a ground fault occurs, part or all of the AC current will be turning on the fault path and not on the two hot conductors. The AC current on the two hot conductors will not be equal and your ground fault protection will trip. Effects of electric current in the human body. 5 milliamps, you will feel it. At 6 milliamps, painful shocks, loss of muscle control. You can't let go. There's many stories of electricians when they're working, they get caught and they can't let go because their muscles contract. At 50 milliamps, extreme pain, could have respiratory arrest, severe muscle reactions. At 1 amp, your heart could cease, nerve damage. 10 amps plus, cardiac arrest. You're really in a lot of trouble there, okay? Protection from ground fault electrical shocks, okay? A lot of it is just taking care of cords, especially stay away from extension cords. If your extension cords are not supposed to replace permanent wiring. Outdoors, Halloween, Christmas, people put up a lot of lights. It also snows, it rains outside, okay? Install proper ground fault receptacles, okay? Residential ground fault receptacles must be tamper resistant. You know, the ones that are so irritating because you can't stick just one prong in. That's so children can't stick a clothespin into those receptacles. More on that eventually, okay? Residential ground fault receptacles must be tamper resistant and weather resistant if they're outdoors, okay? And if the receptacles are outdoors, they must have a weatherproof cover and identified as heavy duty. That's one of those big bubble covers you got to lift up and plug in. There's a reason for them, to keep water out. This is a part one video of ground faults. I also have another video, kind of like a lab experiment that I can demonstrate what a ground fault actually is. So if you're interested more in ground fault protection, check out the next video. Thank you.